So, what we're trying to say is that for you to, when a child arrives in the world, the first thing you do is you name that child. It's very important. That's why we're able to address each other well, to say this is Everdeen, nice name, Doris, Londe, Bien, Editor, Isaac, Tandiwe, Queen. So these names are very important. I'm sure you know that. So we struggle with names. So even when you have your language in your language of chemistry, where do these names come from? These names, all of them, come from an alphabet. So we have in our language, even in our language, just to speak our language of English, the language of English is guided by the alphabet, which is 26 letters in the alphabet. And we're still improving our English. Some of you, up to now, you don't know how to say I love you. But that I love you. So now, for chemistry, the known substances that are there in the world and in the universe, for them, we said the words here come from the alphabet. We combine words from the alphabet, have the letters 26. But for the things in the universe and just on Earth, because that's where we are, the non-substances come from elements. So elements combine to give you all sorts of things that we're talking about. Elements are the ones that combine to give you the compounds. And then when you mix those compounds and some of the elements and there's no chemical reaction there, you get a mixture. So meaning elements are the building blocks of substances that we have on Earth. So what is an element? So to understand chemistry, you must know all there is about elements. What is an element? So I'm sure someone knows. Let me get an answer from you. Who knows what the definition of element is? Let's make this interactive.
Yes, sir.
Moffat, yes.
Um, an element, is fundamental elementary substance that cannot be split by any chemical means into simpler molecules or substances.
Into simpler substances. Thank you very much. Before I land up for one book, I'm sure you have the book that I'm using. Oh, all right. So cheers, guy. That's what we need. We need someone to have a head start, like Moffat has said. So an element is one of those two pure substances. I think I told you that we have two sets of pure substances that are accepted as pure in chemistry. We have a compound and an element. So the compound can be split into elements or simpler compounds. Like water can be split into hydrogen and oxygen. But when there's a chemical reaction, yes, by chemical means. So it can be chemically split into simpler substances, the compound. But for the element is the pure substance which cannot be split into simpler substances by chemical means. So that is the case. Meaning you cannot do a chemical reaction and split the element. So whatever it is, like even when you have copper, whatever reaction that you do and split that's copper, when you share that copper, what you will remain with, all of you, when you go, you will say you have copper, and yet it will just be small in quantity. But then the other things, you can do a lab reaction and split them. So that is the only thing that is there. So one of the things key is that these things, the elements, cannot be split by chemical means. And to you, always, they are pure substances. Anyone to give you an example of any element they know? Anyone? Richard. What element?
Oxygen.
Oxygen, yes.
Carbon.
Carbon, yeah.
Right.
Nishi mupili mukiremayo baba Doris microphone.
Sa narachinja.
Ba Doris. Nishi batoge kwene. So apparently mwabika pona verse ka. Oh my God has blessed
Sa
me.
narachinja.
Tonga. Tonga.
Yes, sir.
You want to say something?
No, it was just a mistake, sir.
Tracy. Tracy Kadipa.
There's also gold, silver, iron. They're also elements.
Oh, they're also elements. I think that's okay. So
A
now,
couple of
guys.
elements, copper and lead.
All right, that's good. So no one will ask you to say name two elements. It's a foundation. But you should be knowing which one is an element, which one is a compound, and what forms they exist. E.g., I know in your grade 12, you talked about diamond and graphite, that they are forms of carbon. So someone can hide the question in that perspective and ask you, what is the element here? Then, for the diamond, pasabana petroleum products, mimpabana ethane. Hello, adawata pale monega po element here predictable. Then you should remember the allotropes of carbon. So you should know the forms in which some of these elements are found in nature. So now, very beautiful guys, you are very sharp. So these elements are ordered, or they are numbered in order of increasing complexity. Era muma guys ngo urefu afipwe na mfiapo kwa that is complicated. So for us, the simple is the light element. Then the complex is the heavy one. So the simplest element is hydrogen. So those ones, they are ordered in order of increasing complexity, or numbered in order of increasing complexity. You find hydrogen is there as your number one. Why? Because it's the lightest mass. Then you also have there's after hydrogen, there's helium. You see that one. You don't really have to go and master them, but you can know maybe the way we're forced at grade 12 in our case, you can try to have an idea of what the first 20 are, just for you to enjoy. But always know that whenever you're tackling a chemistry paper, a periodic table is always there. If it's not there, then the details that you expect to find from the periodic table are also given. So if you look at the periodic table, the hydrogen and the helium, when you have them there, their masses are increasing. as you are going. When you go to lithium, the mass has increased a bit. So that's how you arrange the elements. But then these elements in nature, they are not found like you don't find elements in nature easily. Like they are not found in their free state in most cases. The ones that can be found in their free state, the only one which can be found in its free state sana is gold. Gold. It can be found in its free state. It's very non-reactive. It's very non-reactive. Even you in your life, if you want to be valuable, don't be reactive to anything. Kuliladila, ukutemwisha chitemwiko. Ngoba fe independent, you'll be like gold, the free substance of value. So gold is found in its free state. Silver is also found in free state, just a bit, but some of the silver is in compounds. So, but the rest are found in compounds. The rest of the elements, most of the elements are found in compounds. Then some elements that we have in nature, I think I listed them. There was technetium, promethium, astatine, and francium. These ones, we said they either do not occur in nature or they have transitory existences, meaning for you to have them, they only exist briefly when you do a lab. They exist briefly, then they become something else. But most of the elements that we have, they're in compounds. That's why industries are set for purifying, removing your element from the compound. That's why you have a mine. I'm sure you've seen them. Oh, there's a mine in Kitwe. What they're trying to get is copper. But you can't just find copper you get copper in a compound, then it will be purified. It will be purified until you get your pure copper. It's a process just to get your copper in its pure state. Just like a partner in the world, you don't just find your partner usanga chitapangika mu bantu abengi tamwisho nokumwishwanga ni nani, then wamba okufwaya era wamupanga wemwene wamusambika wamushitashani era wakubutuka palast. So those are the things that are there. Are there any questions? Are there any questions where we are?
Yes, sir. So, do you have to know all those elements that you listed below, like the one which don't, which are not found on Earth?
In nature, naturally, what you meant is natural, not really on Earth, but naturally, like
Okay.
you can't encounter it. Waitola fyokutira mudi astatine. For you, it means for like during radioactive decay, that's when it becomes astatine. Then it becomes something else. They're just four. You can have an idea of what they are: promethium, astatine, francium, and technetium. And I'm sure those of you who've done radioactivity at length, you'll remember that these things, you knew them. They're just four. You can have an idea about what they really are. So what we've said is that you can decompose a compound, but you cannot decompose an element chemically. Yes, Davis. Okay. So now the next thing is because we're talking about these things, I'm sure you're disappointed. You wanted me to have like a paper explaining, but then there's nothing to solve. We're just going through our notes. So let's just see. When you have your time, when you go through, I want you to like to read through our notes. Is so atinga mwamko ya birenga mo yele panga sense. If we lay a panga sense. So now the next thing is that you must know that the simplest element, like if you have a house, the simplest you have is say a block. A block. We say we have a block, that's the simplest. although someone will say cement, like a grain of cement is the simplest. So the simplest or the building blocks of elements are called atoms. The building blocks of elements are called atoms, meaning the building blocks of compounds are called molecules and formula units. So I'm sure you remember molecules, a molecule, and the formula units. But now in this case, what makes an element is an atom. The definition of the atom, anyone remembers the definition of the atom?
An atom is the smallest particle of an element. That's what I remember.
That can
Sir,
go then.
so I have a question on that one. Yes.
Actually, I define
If an atom,
Mulefo could define an but because chose
Sir?
defining. Yes, I'm saying we are waiting for the definition of an atom. Are you defining?
I wanted to ask a question, sir. I have a question.
Yes, you can ask.
My question is, we earlier defined an element to be something that's indivisible. Then when we actually make a relation to an element and an atom, we find out to say an atom is the smallest particle of an element that takes part in a chemical reaction.
Yes.
Doesn't it give us a sense of meaning that an atom is made of a specific element, but we're saying that an element is undivided or cannot be divided? I want a bit of clarity on that, sir.
Okay, nice accent, sir. Nice accent. Naomi. My Baba Naomi. Okay. Naomi, you have something? Good then. Very good question. I'm sure this is where we want to be, and this is where I want to go. So the simplest, the smallest element that can be there is the atom. Meaning simply that an element is a group of identical atoms. So the smallest thing you can have as the element is the atom. So the atom is, that's why you know on your periodic table, it's called periodic table of the element, but what you have there are atoms represented. So it's the smallest representative part of the element that can stand and say it's also the element. So the element, the atom, is the small element. The smallest element that can possibly be there is the atom. Meaning when the atom enters the reaction, it will react the same way the big element will. That's the reason in there. Even when we have our chemistry, our elements will almost always be represented by the atom. So the atom is the representative. It is the class rep of the element. It's like you get a sample. It's the sample of the element that is the atom. So the atom is one that will enter the chemical reaction and react the same way as the entire element. Though humans, you cannot say someone is representative 100%. Humans are different, but that's how it is with the atom. Atom is part of the element. The atom is the element. The element is groups of atoms that are identical. So that is the reasoning there. Except you remember that atoms still have smaller particles, which we call the subatomic particles. These subatomic particles, what do we say about the subatomic particles? The subatomic particles are smaller. I'm sure you remember that they are smaller particles, and they are protons, neutrons, electrons. Those ones, they do not have the properties of the element, but the atom has the properties of the element. So that's the thing. So the atom is the representative of the element. So that's the thing that is there. Then the next thing, briefly, that I can talk about is that when you talk about the distribution of elements, how elements are distributed like wealth. Wealth is not distributed equally. Very few ever kwatafena ni chuma, then the rest ba no fear, like tabakwatane shing. So it's same with the distribution of elements. So you find very few, and most of the times, very vital. The best things in life are free. The best things in life are free. Like the most abundant element, oxygen. It's the best. You can't go in this life without breathing. I'm sure you know. But it's for free. To endafe, what? It's no, it's my what? But then the ones that we have attached more value to, like gold, talk to him money. I'm sure you've seen how we struggle just to get a bit of these things that we've attached value, monetary value to. But most of the things, so that's the thing. Then one of the things we can have. So one of the things on the distribution before I say so much, one of the things I wanted to emphasize is that when you have elements on the periodic table or elements in nature, the way it is that two elements are liquids. Two elements are liquids, and those elements are mercury and bromine. Mercury and bromine are liquids. Then 11, these 11, you must master them, you must know them. 11 are gases. 11 are gases. 11 are gases. So those ones, you must know them. The noble gases, if you look at your periodic table, then you have hydrogen, nitrogen, oxygen, fluorine, chlorine, then all the noble gases. Those are gases. Try to understand it from that perspective. Meaning the rest of the elements are solids. Remember, we're talking about elements, but some of you brain and will meet you. It's a compound. Because I'm going about brain now. If balanda chama only to her are liquids. So don't struggle that much. So are there any questions, guys? So one of the things that I was talking about the distribution, I said very unequally. 99% of the mass is only 99% of the mass of the Earth's crust, seawater and atmosphere, meaning of the world. 99% of the mass is only made up of 10 elements, imagine. And then the 1% is the other things. With oxygen as the most abundant. Why oxygen? Because found in water, it's found in sand. Remember, sand is silicon dioxide, not so. So it's found there. Those are things. Then another element which is very abundant in the world is quartz, which is silicon. Silicon is found in sand. Imagine for something to be found, sand for if sand was money, and the life would have no value. So those are the things. I've put all those parts in your notes because I want to rush so that you understand. So guys, I want you to remember those aspects that I've mentioned. Then when you see the names of elements, I'm sure you did in grade 12, the names of elements come from different sources. That's why you have different symbols on the periodic table. Let's say copper, you find Cu. Silver, you find Ag. Those are from different sources. That's why they were named there, and you have those aspects. Some names, there's a background why they were named the way it is. I've put it in your notes. Then the next thing is you must know the symbols. You must know the symbols. You must know which one to capitalize. Because some of you don't know up to now. Kudawa muntu alekupela asa kupela carbon monoxide na cobalt will distinguish. You must be able to distinguish elements. Is a language. It's a language. So you must know that first letter you capitalize, you emphasize the capitalization. Then the next other letters, or the next letter, or if it's 2 or 3, the next letters you put in small letters. So try to remember that on symbols and all. So I think that's about all that I've put there. That's about all that I've put there. So what I want to emphasize, I'm sure we'll get back there, is that some elements exist as diatomic elements, as diatomic molecules, e.g. hydrogen, oxygen, nitrogen, and all the halogens, hydrogen, nitrogen, oxygen, and the halogens. The halogens are the chlorine, fluorine, remember those things, the group 7 elements. If group 7 for our grade 12 years. So now, those ones, they exist as diatomic. So if someone says, hydrogen enters a reaction, but this hydrogen is H2. Oxygen enters the reaction, this is O2. So those are the things you must know. There's only about 5 minutes remaining for me to close, but I've said the important things that are there. Topic on periodicity, when we look at the periodic table, and now we group elements there into metals. You can go and read ahead. Metals, non-metals, metalloids, those things. You now get a workshop because you keep then you understand the application. So what I've emphasized that so mamona guys on oxygen reacts with copper. Ufidewashbati oxygen ni O2. Hydrogen is produced when a metal reacts with water. You should know that hydrogen is H2. Why? Because it exists as a diatomic molecule. Don't struggle with these things, guys. They are simple. Who has an addition of anything? I can ask for an addition.
Submit a question, sir.
Yeah, Moffat.
What are diatomic elements?
Diatomic elements, they exist in nature as molecules of 2 identical atoms combined, e.g. O2, H2, N2, Cl2, F2, I2, Br2. Those ones exist like that. So every time someone tells you chlorine reacts with sodium, chlorine wala bika of Cl2, but sodium wala bika for Na. Why? Because chlorine exists in nature naturally as a diatomic molecule. Are we there? Yes, guys.
Yes, sir. Can you repeat a little bit on what you said about how elements are not equally distributed?
They are not equally distributed, meaning the masses of the entire world, the composition is mostly 10 elements. 10 elements. Even the mass in our own bodies, the composition is different. So you find there is, even in nature, like even air, if you remember air, biggest mass there is nitrogen, oxygen. The rest are very small things. So that's what we mean by they are distributed unequally. Meaning, if you talk about the same, like wealth, I gave an example of wealth where very few people have a lot of money. FB status, but so that's the thing. Like the masses of the universe, the things like sand, it's in abundance. It's in abundance. Ngoli ku beach fingi nga ndalama sand kumfa bwino, but $10 iyo. But the other things that we have attached value to are very little. Some of it, for you to have it, some of the things, some of the elements were just made in the lab. So it's very little. That's what we mean. Distributed unequally. Unequally meaning the masses are variable. Like the fiber no oxygen, carbon, they have the same mass. No. Some of the elements have a bigger mass, but then some have a very small mass. That's what we mean. Are we together, Madam Doris?
Yes, sir.
Okay.
Sir, I have a question, sir.
Yes, sir. Yeah.
Okay, sir. You were talking about the atomic substances where you talked about nitrogen, oxygen.
Yes.
Does this affect its reactivity series in terms of how it reacts with, let's say, a metal reacts with oxygen according whether it's at diatomic or not diatomic?
What that means when we say diatomic, it means oxygen cannot even enter a reaction as monoatomic. It will always be diatomic in nature. And that's the case of ozone. So what you have for oxygen, when you just say the word oxygen, for you as a scientist, you will know that ni O2. I'm sure number fume O2 fume. Why? Because oxygen will always enter the reaction as O2. It can never exist as O.